This is the phase transformation lab. The goal of this lab is to identify the eutectic composition and phase transformation temperatures of a few unknown mixtures of tin and zinc. Each of the unknown samples will be put in a crucible. And so what you're going to do is take the crucible and place it within the heater. Make sure it's turned on to high so that the mixture completely liquefies. And after the mixture is liquefied, what you will do is place a thermocouple within the mixture and use a thermocouple reader to read the temperature. To begin the lab, you will insert the sample into the heater using the tongs. While the sample is heating up, you want to make sure the thermocouple reader is working with the computer. To do this, you'll first need to select the proper COM port. Open Device Manager and select Ports. The thermocouple reader should be identified as a USB serial port. In this case, it is in COM4. And so if we go back to the HH506RA software, we will see that COM port 4 is selected. So we should be good to go. You will then select the T1 input option and a window will launch, and you will want to make sure that the temperature value in that window matches the actual value on the screen of your thermocouple reader. In this case, it does, so we should be good to go. Now, a common error you'll experience is the RS-232 error. This usually signifies that there is a break in the connection between the reader itself and the computer. To fix this, ensure that your USB serial cable is plugged in all the way to the computer and the thermocouple reader, and then select T1 input and start again, and that should fix the problem. After the sample has fully liquefied, you can begin data collection. On the software, select T1 input and then start. A new window will open, and then you will go back to your original window, select record, and this will launch the record window. In this window, you will hit the REC button to record the data. Make sure you select the user file option in order to select where you want to save your data. Then hit REC and choose where you want to save your file. Only at this point will the temperature data begin to be written to a file. After this, you are welcome to open the graph in order to see a visual layout of the temperature data over time. Once you've done this, you can now remove the molten sample from the heater. When you remove the molten sample from the heater, you should begin to see a sudden drop in temperature. You'll be looking for a point on the graph where the temperature begins to level out. This means that phase transformation is taking place. I would recommend recording this value, but be sure to continue recording temperature data after this phase transformation takes place to ensure that this actually was the location where phase transformation took place and not just a small blip in temperature values. After recording sufficient data, select the stop option to stop data collection. At this point, you are welcome to open the Excel file of your recorded data, and you should see all the temperature values over time. After determining the phase transition temperature of this sample, complete the same steps with each individual sample to determine their phase transition temperatures. Then refer to the tin-zinc phase diagram to determine the eutectic composition of each individual sample based upon its phase transition temperature. Refer to lab documentation to know how to best report this data.